Hello, this is the, wait, what is this? This is the 2002 Regionals Maths Contest Live Solve. It's going to be the same format as the other Live Solve. Like, I haven't seen these problems before. So yeah, like, this is kind of like my raw thought. So, this one, oh, let me first get my calculator out. I don't even know where that, oh, found it. Okay, if needed, I'll take a picture of it, but yeah. Okay, just connecting that. Alright, so basically, yeah, okay, this one you just need to find the restrictions on x. It doesn't look like it's anything too fancy. So to solve for an absolute value, just split it off into branches. This is x is less than -2, and x is greater than 7. So the sum of all of them that is in this restriction, you just go through them. 14.82, one sec. Yeah, okay, 14.8, I'm typing this in my calculator. 14.82, -4.38, or 31, 16.83, -3.72, -8.79, and 12.1. Adding them up, you should get the answer of 2684, and I'm gonna check the answer key, and yeah, that's right. Okay, nice. Okay, sorry, I just got distracted. I saw a notification on my phone. All right. So now, this one is, yeah, okay, this one is the second problem. Okay, so taking the average, all right, yeah, so the average, if you don't forget, the average is sum over number. So 2 plus 5 plus 16 plus 13 plus 11 plus 102 plus x plus 19 over 8 is equal to 25. I'm just going to use my calculator. That is, one sec. That's 168 plus x over 8 is equal to 25. 200 is equal to 168 plus x. X is equal to 32. Okay. Next problem appears to be a Venn diagram problem. Interesting. Oh, but there's only 2 categories, so you don't even need to draw the fancy picture or anything. I'm just going to let F be the people only taking French, S be the people only taking Spanish, and then B for both. Do I need any other variables? No. So first sentence tells me F plus B is equal to 84. Why is it F plus B? Because I'll draw the picture to see what I mean, but this is only F, like no intersection. This is B. See how F plus B makes up the entirety of French? So yeah, that's like why it works. So F plus B is equal to 84. S plus B is equal to 76. F plus S plus B, which is all the people in the like school, that is 136. So what do I even have to solve for? I have to solve for both. Okay. This doesn't look too bad, just because if you add these two, that's something I recognize. That gives you 160, and then subtracting these two just give you B is equal to 160 minus 136, just because system equations, just giving you B is equal to 24. Okay, that's the answer. Nice. Okay, problem 4. We're going at a pretty good pace here. Arthur and Judy are 292 miles apart, so tells me this is going to be a D equals RT. At 11 p.m., they start and continue at each other. So one of the rates is negative, the other is positive, because if you think of a graph, one's going like this, one's going like that. And then this one's at, this point is at 292. And then I don't know any of the rates, but I know Arthur is just equal to R plus 8, while Judy is just equal to R. And I need to solve. Oh, and this sentence is pretty helpful too. I just skimmed the problem and completely skipped that sentence. Okay. So for Arthur, I'll just say Arthur's the one starting here. So he's just equal to his speed, or no, his position, I'll just denote that as A, is equal to R plus 8 times T. no initial value, and then Judy is equal to negative RT, because she's going down, but plus 292. And I'm given that J minus A is equal to 40. So plugging in 3 for time, because 11 a.m. is 3 hours before 2 p.m., negative 3R plus 292 minus 3R minus 24 is supposed to equal 40. And then, so negative 6R is equal to, I'm going to unplug my calculator from my computer. 40 plus 24 minus 292. 40 plus 24. Okay. And so that is equal to negative 228. And R divided, and then solving for R gives you 38. But is that the answer? No, because we need to find Arthur's rate, which is R plus 8. So 38 plus 8 is equal to 46. And then, yeah, the average rate, that's just, don't like read too much into it. That's just the rate. But yeah, okay. Okay, moving on. Sum of three numbers, so I'll just say A plus B plus C is equal to 77.9. Difference between the largest and smallest, so I'll just say C minus B is equal to 20.6, and then the product, wait, the largest and the smallest, oh no, A. I'll just have it in order, and then product of the two largest, BC is equal to 896.52. And I have to find the largest of these three numbers, which is pretty annoying because I have fractions. Or no, not fractions, sorry, decimals. I guess I could just substitute, because if you think about it, A is just equal to C minus 20.6. And then what else? C is also equal, no, sorry, B is equal to 896.52 over C. So C minus 20.6 plus 896.52 over C plus C is equal to 77.9. And this is nice, I guess. I'm going to use the numeric solver because that's a thing you can do because it's a calculator one. So if you don't know what that is, I will load up my TI Connect. I really wish I had the license, man. That would have been nice. Because then I don't have to like do this weird calculator screenshot thing. Maybe I'll start editing my videos. I think that's what it is. But yeah, so this was the original calculations, I guess. This was from a previous problem. So if you go to the math button, you'll see a menu like this, right? And then if you click the up arrow, and click enter, you'll see something called numeric solver, and it looks like this, right? And this is another way. This is actually how I solved that problem first, like in the same video. Then I realized like what I realized. Yeah, I realized that you probably didn't know how to use numeric solver, so I guess this is a good tutorial on how to use numeric solver. But yeah, basically, you put this equation here. So I'm just going to type in x minus 20.6 plus 896.52 over x plus x is equal to 77.9. It looks something like this. Not gonna lie, I wish I just used it for that first problem too. I had it typed in and everything. I just thought, oh, maybe these guys don't know how to use it. Okay, but you do this, then click the OK button, which is the graph button, and you'll get something like this. Now, here's the important thing. You gotta realize your context of solutions. This, oh, I can just have here. This will give you more than one answer for x, because if you solve for x, you'll get a quadratic, right? Now that's bad, because quadratics have two solutions, and in this case, can C be 12.05? No, because think about it, we go back to our calculator, and we're here. 3 times 12.05 is nowhere near the sum. And the reason I say that is because 12.05 is your max number anyway, so this is the max sum you could ever get. So now, what I'm going to do, go back to numeric solver, and I am going to click OK, and then where it says bound right here, This is just the bound, like -1 E99. That's just every single number pretty much that the calculator can handle. I'm going to type in 12.06 because it's inclusive. So now you'll have something like this. And click enter again. Oh, and you'll get bad guess if you don't change it. If you get bad guess, it's the menu that looks like this. Click go to, and that's because your X value here needs to be in the interval. So just change it to like 0.061, like this, or something like that. And I'm going to click solve again, and I will get another answer, 37.2. Now I know that this is a quadratic because of just context, right? So, but you could change the bound one more time to see if you get any other solutions. You'll get like an error sign change if it doesn't work, but x equals 37, or c equals 37.2. That's the only other solution, and that makes sense because it does make sense to be the biggest number, so that's just your answer. Okay. All right, 6. Okay, so the solution. So x, what are the solutions for x? Well, x can equal 0 because that's this root. X can equal 1. What's this factored? Can it be factored? Yes, it can into this. So then -5 and +2, and then can this be factored? Yes, it can. There's x minus 11, x plus 3. Okay, nice. So 11, -3. Now the amount of negative, so it's just a number of negative over number total. This is just equal to 6 total roots, and then 2 of which are negative, so 1/3 is your answer. Okay. Okay. Number bases. Okay, I always like problems like these. Basically, I know we haven't covered number bases in any of the like videos, but basically, 34. Like, if you a quick crash course, if you have like the number like 1, 2, 3, 4, base 4, expanding that out is just 1 times 4 to the third, plus 2 times 4 squared, plus 3 times 4 to the first, plus 5 times 4 to the 0th, which is just 1. How does that come from? Because in normal, every number that we usually deal with is in base 10. And if you remember, an expansion of any base 10 number, that's just 1 times 10 to the 4th plus, or no, 10 cubed plus 1, or 2 times 10 squared, etc., right? So, therefore, 34 to the base x, that's just 3x plus 4, and then that's equal to 2x plus 5, or no, 2y plus 5. Combining like terms gives you 3x is equal to 2y plus 1. All right, so now we have to find, so now we have to find cases of x based off y. Okay, so we have to find out first of all, what are the possible values of y? Y is in the range, or in the like possible set of perfect squares, so that's just 9, 16, 25, 36, 49, 64, 81. And if we plug in y for this equation right here, we should get a integer for x. So that means that 2y plus 1 must be divisible by x. So let's see what works. 9 definitely doesn't work because 2 times a multiple of 3 plus 1 is not a multiple of 3. It actually leaves a remainder of 1. So that doesn't work. And similarly, all multiples of 3 won't work. So 36 is a multiple of 3 and 81 is a multiple of 3. Okay, now we have 5 cases left. The 16 works. 16 is 32. 32 plus 1 is 33. So 16 works. So I'll say y can equal 16. 25 makes x is 51/3, which is a multiple of 3. 49 is 98 plus 1, which is 99. So that's a multiple of 3. Then 64. 2 times 64 is 128. 129. 1 plus 2 plus 9 is a multiple of 3. So 64 works. Wow, that's perfect. Okay. So now 16 plus 25 plus 49 plus 64. I'm going to use my I'm going to use my calculator for that. 16 plus 25 plus 49 plus 64 is equal to 154. Okay, boom, nice. All right, let S represent the sum of 12. Okay. So this is a series problem. If S is the cube of a positive integer, find the smallest value of the smallest of the positive odd integers. Okay, is there any identities that I remember? I know the sum of squares, no, the sum of odd numbers is a perfect square. Like if you do 1 plus 3 plus 5, whatever, that's a perfect square. It's asking for a perfect cube. And it's not even, okay. I think I might just figure it out, like, so you have, say you have 3 positive integers. That's just a plus 2, and then a minus 2. But that's actually not nice because we want to find the smallest possible value. So I'll just start at a. So we have a, and then the sum of a finite arithmetic series, so I'll just say S, is number of terms over 2, or actually better yet, think of it this way. Number of terms times the average of the first term, so I'll just say A, and the last term, which ends up being like A plus, n minus 1d over 2, right? A plus n minus 1d is equal to the last term. And then a is the first term, so that's where that comes from. So we can literally just plug it in, right? So S is equal to 12 times A, I don't know what that is, plus another A, plus 11 times 2, because it's consecutive positive odd integers, so they differ by 2, over 2. Okay, that's cool, because that just ends up being S is equal to, sorry, someone's calling me. Okay, S just equals 12 times A plus 11. So, now what? This must be a perfect cube. And there's 2 ways of going, but you can literally just plug in every single number and see what works, right? You can plug in 1, you can plug in 3, you can plug in 5, you can plug in 7. Chances are you'll probably find the answer soon enough. And yeah, but is there something smarter we can do, which guarantees us a more efficient solution? And in this case, I'll try doing that because I don't really like casework solutions. I feel like they're lazy and lame. So, yeah, basically, like, I'll figure out a smarter way of doing it, right? So S, I'm going to prime factorize this as 2 squared times 3. Now, for this one to be guaranteed the smallest perfect cube, we basically have to make this as perfect cube as it can get. Now, what do I mean by this? That means that to make this a perfect cube, the powers must be divisible by 3. So because of that, when you multiply, a plus 11 must be equal to 2 to the first times 3 squared. Why is that? Because say we do that as 2 squared times 3 to the first times 2 to the first times 3 squared. That's just equal to 2 to the third times 3 to the third. And then cube rooting that just gives you 2 times 3, right? A perfect square. And we're not introducing any other funky terms, so it works out. So a plus 11 is equal to 2 times 9, which is 18. So a is equal to 7, and that's the answer. Pretty small number. It's also odd, so perfect. We get our answer, and we are done. So yeah, a equals 7. Is that the right answer? Yes, it is. Okay, that would be really embarrassing if it wasn't. Okay, pretty cool. Oh, this one. Okay, I don't even need to really like go. Actually, no. It's good if I show why this is true. Off the bat, the answer is 16. I'm like 99% sure of that because there's a really, I don't know why it is. ICTM always asks us this, thinking they always stump us. But it's really like, if you memorize it once, you'll never forget ever again. So basically, say you have a set P, right? I'll have this as like a set, right? So I'll just have this A, B, C, D. A subset is like, I don't know, like A, B, or like B, C, D, right? or like even nothing, which is called the null set, right? Or the full subset, which is P, is A, B, C, D. That is just denoted as P, right? So how many different ways are there? Like, this is a really nice combinatorics problem, because it's like, think of it, right? I have two choices. I either, for every set, I either include this one or I don't include it. So I include or no include, right? So because of that, that's just going to be two choices, and then same for everything else. So the answer is just 2 times 2 times 2 times 2, which is 2 to the 4th, which is just 16. 16 is your answer. And yeah, and also notice that this does include the empty set, and this does include P. Why? Because if I made the choice to not include any of them, I'll just be left with a null set, right? If I included all of them, I'd just be left with P, right? And that's actually cool. And even when you get to like, when you start reading like other math papers and stuff, you'll actually see if they ever do anything with like set theory, they'll actually denote the set of all the subsets as like 2 to the, I think it's like 2, like say if you have like 2 to the P. I don't know for sure, but I know there's a 2 to something. So yeah, pretty cool. Yeah. Okay. Oh crap! Just dropped something on my desk. All right, moving on. Oh, fractions. Seven-eighths of Farmer John's male hogs are white, and 1/3 of his female hogs are white. The total number of... Okay, so M plus F is 28. That's the easy part. And then 7/8 of farmer. So then 7/8 of M are white. F over 3 are white. What? Oh, I understand. Okay. This is... Okay. So basically, you know that these two both have to be integers, right? So because of that, first thing, F has to be divisible by 3, and then M has to be divisible by 8, right? So I think, is there a better way to do this than the way I'm thinking of? But okay, I have no other idea just to do casework. Because, for example, M can either be 8, 20, no, 8, 16, oh, it is not. M can either be in the set of 8, 16, 24, and that's it. Because way more than that would screw you over, right? And why is that true? Because think about it. Then the number of white hogs would be 7, 14, or oh yeah, pretty much, or 21, right? And then plugging in, if I have 8 plus F, then F has to be 20, but 20 is not divisible by 3. Right? Yeah, I might be overthinking something. Actually, no, that makes sense. Okay, so it can't be 8. Or if I plug in 16, 28 minus 16 is just 12. So if F is 12, that works. Because 12 divided by 3 is 4. So that does give us the potential solution. Is that the only solution? Because sometimes they might ask for more than one solutions. So, what I say, 14 plus 4, that's the white hogs, is 18. Is there any other solution? If M is 24, F is 4, that's not divisible by 3. So 18 is your answer. Why? Because they both have to be integers, right? 7/8 of M has to be an integer, so it's M can either be 8 or 16. We tried 8, then F is not an integer, but if we try 16, F is an integer. So 18 is just your answer. Is it okay, perfect. It is. Nice. Oh, crap. Oh. I hate big problems, but 90% of ICTM big problems are just like... they're what? They're like... They're like really like they're yap. They just have a lot of yap in them. Okay, so 100 in an account that earns an annual percentage rate compounded quarterly. And then the interest accredited to why are they asking to express your answer in cents? That's so goofy. Oh, because it's probably a really small amount. Oh, okay. So, compound quarterly. I'm trying to remember actually. What is the formula that I think if it's compounded quarterly, it just means 100 times 1.08 times 1.08 because you're compounding after 6 months, which is just 2 times. That is equal to okay. And then wait. Something feels wrong. Because that's a lot of money. Oh, are you supposed to divide? I actually can't remember the formula. I haven't used this formula in forever. Part of me wants to actually Google the formula, but it might be in... there's a finance thing on your calculator, which I often consult. Is it 1.08 divided by 4? So 100 times... Okay, I actually cannot remember this formula. This is actually bugging me. I am probably just gonna... compounded interest. Okay, this is kind of cheating, but... okay. Yeah, I could not remember. Because I know, like, when it's compounded annually, that's easy. It makes sense. But I always forget this formula. And it's nice because I usually have this formula written in my calculator. Right? Do I actually have my programs? Okay, I don't have my programs on my formula. Or, no, I don't have my programs on my calculator, but usually I have you're allowed programs on the calculator. So if that happens, literally just plug in, plug in all the formulas you forget. This formula is always on my calculator, so if I forget, I just do it. It's not a big deal. So I guess it's not cheating because I would, in a real competition, I'd be prepared. Right now it's wiped because I haven't done, actual ICTM problems in forever. So the number is just equal to 100 times 1 plus 0.08 over n, which is 4 times 4 n. 4t, which is it a month? Oh crap. No, because 4 is a year, so this would be 0.5. All right. Now plugging that in. All right. That makes more sense of an answer. That gives you a is equal to 104.04. And then minus 100, because we're only looking for 100 or interest, that's just 4.04. So your answer is just 404 cents. And call me out for Googling the formula or whatever, but I would have this formula written down in my calculator regardless, so I would have known it. But yeah, I guess that was a moment of weakness. But hey, at least I'm honest, right? Okay. Do I even want to? Okay, actually, I know how to do this without even needing to do work. There's a program to do this as well, but I guess I'll just show rise of a run. 195.39 minus or plus 14.3 because of the negative over 18.73 minus 2.6. That is equal to 13. Okay, so 13 is a slope. Oh shoot, what'd I do? All right, 13. What problem am I on? 13, okay. Oh, wow. It's at an angle now, so that's kind of annoying. Mary has 15.7 in dying quarters. Oh, system equations. Okay, so I'll convert everything to cents. 10D plus 25Q is equal to 1570. And then 18 fewer dimes in quarters. So Q minus 18 is equal to D. Oh, and I actually have to find out both variables. Okay, that's annoying. Basically, 10Q minus 180 plus 25Q is equal to 1570. 1570 plus 180 divided by 35 is luckily an integer. Q is 50. And then Q minus 18 is 32. So 50 plus 32 is equal to 82. All right. Wow. This one looks long, but I think it's just a definition. Yeah. First one's just the definition of like the sum, which is fair. Sum of squares is just that. Okay. So okay, that second part is really easy to write. And I think what you have to do is find an expression for it and then figure out what you want to do from there. Like, you have to find an expression and then combine them, and you'll get something in the form of ax cubed plus bx squared plus cx. Okay, so is there a nice way to combine them? I have an idea that uses like more of a like fancier notation. Because if you think about it, this is just this first part gets up to x. So it's basically just saying like x. Okay, say you're basically summing up to n, right? Then what you're doing is basically doing x times n minus, x plus I, and then x minus, no, and then, yeah, that's right. X minus n, does that make sense? No, because that would just give you, wait, it's not this, but it's close. Okay, this is kind of embarrassing that I can't figure this out. Okay, it's the first term, right? Say I is, what, like the I and the n are just like placeholders. How do I make sure that term is counted? That's the problem. Oh, wait, the second term isn't even reliant on x, right? Or is it? Oh, I think it's actually x minus I times I plus 1. Does that make sense? Because say you plug in for the 0th term, it'll just be 0. And then for the second, or for the first term, it'll be x minus 1. Okay, boom, this is it. Okay, perfect. And now this is just summed up to n. So the fancy way of writing that is like this. With the sum sign, you start at I equals 0, and you sum it to n. Okay, perfect. So now what? So basically, this just turns into xi plus x minus I squared minus I. Okay, and now, and then I is just basically just a variable that goes from 0, 1, 2, 3, all the way up to n. So xi is equal to 0x plus x plus 2x, right? So that's just equal to x times 1 plus 2 plus dot 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 up to n. So xi is just equal to x times whatever definition it just gave you, n times n plus 1 over 2. Why does that feel wrong? Oh, x is just your variable. And then I squared is equal to x plus 1, 2x, or wait, yeah, 2x plus 1 up to, or wait, actually, before I even do that, I just realized this is also equal to I squared. Yeah. Okay. Yeah. Okay, perfect. So then this actually cancels out. Funny enough. So we're basically just left with xi plus, wait, one sec. I kind of feel like I'm gonna cancel that out in a second, because I'll just say that plus the sum of I is equal to 0 up to, no, I is equal to 1 up to n. The only reason that's relevant is because you don't even need to okay, I is equal to 1 and that's up to n. That would just be the definition it just gave us, which is I times I plus 1 times 2i plus 1. Or wait, no, that's not true. What am I saying? This is just I squared. So that is just equal to n times n plus 1 times 2n plus 1 over 6. Now, what is n? N just so happens to be any positive integer, because that's just our max. So I can actually replace this with just x. So x plus 1, 2x plus 1. So x and n are interchangeable. I should have just started off with that. So this actually just turns into, I'm just going to erase this actually because it's kind of redundant. Just turns into n minus I times I plus 1, where I is any integer. Or I is an integer is ranging up to n. Okay, we're nearly there. So now, n times I, so your max value, or wait, actually let's, better yet, just get rid of the n's entirely. So x times I plus x minus I squared minus I plus yeah, okay, and then this is in the sum. So now we have to evaluate the sum, right? So this sum can just be broken into different sums, where it's basically like no, I'm gonna erase this plus. Okay, so this sum just turned into the sum of x's. So that's just x. Wait. Yeah, x times x plus 1 over 2 plus x. Would it be x squared actually? Because there's x's. Yes, it would be. Or would it be x plus 1? Because we're starting at, that should be x plus 1. Then minus I squared, which is just equal to x times x plus 1, 2x plus 1 over 6 minus I, which is just x plus 1 over 2. Now something seems wrong because I have this extra term, which, because this is 1, because this is just, yeah, x plus xi is just equal to 0x plus x plus 2x all the way up to x, actually. So then this is just x times, so this would be x squared. Okay, we're nearly done. Okay, and then now what? I think that's it. Because I squared is just equal to your sum. X is just that. And minus x. Wait, what am I subtracting in? Oh, yeah. And minus this. So, or plus this. So this just cancels out. So now we're left with x squared times x plus 1 over 2 plus 2x, x plus 1, 2 plus or minus x 2. Okay. This does seem wrong because it's supposed to be a cube. Is there anything I'm missing? Wait, I'm just gonna double check my work again. Okay. I think this looks right. Alright. I guess I'll just find out. Oh, because there is a cube actually. Okay, so x cubed plus, and is it all divided by 2? Yeah, it is. Okay, divided by 2, x cubed plus x squared plus 2x cubed plus 2x squared minus x squared plus x. Now I'm going to check if I did the actual foiling right. Yeah, I didn't. X cubed plus x squared, 2x squared plus 2x, x squared, x. Okay, now this cancels with this. So we're just left with x cubed plus 2x squared plus x over 2. So then that's just a plus b plus, okay, so then 1 plus 2 plus 1 is equal to 4. And is that the answer? It is. Nice. Okay. That was, I'm not gonna lie, I feel like the reason I kind of overcomplicated it was because I was trying to explain it out loud. Like, I feel like in my head I wouldn't have, because the reason, when I was explaining it out loud, I kind of trip over my words and I kind of like get confused. But yeah, it kind of like made it seem harder than I was supposed to. I think this is actually all redundant. It was nice to have, but yeah, sorry for making that so complicated. Kind of my thought process was break it down into littler sums. This is the notation you'll see. Get used to it. It looks scary, but it's really helpful because it shows a lot of stuff. So then stuff cancels, and it's a pretty nice problem, actually. But yeah, 4 is the answer. Okay, moving on, because I killed a lot of time with that one problem. Might have been like 6-7 minutes. Okay. Hot water faucet, 8 minutes, 6 minutes. Oh, okay. So basically, hot water is like, I'll use H times 8 is equal to 1 tub. Cold times 6 is equal to 1 tub. And then E times 5, where E is negative, is equal to 1 tub. Okay, and with an empty tub, both faucets are turned on, and the plug is pulled for 3 minutes. What do I have to find out? Okay, empty, yeah, the last problem killed my brain. Okay, with an empty tub, both faucets are turned on, and the plug is also pulled for 3 minutes. So it's basically just 1 over 8 plus 1 over 6 minus 1 over 5 times 3. Then the water faucet is turned off for 2 minutes. So now it's just plus 1 over 6 minus 1 over 5 times 2. And the hot water faucet is reopened, giving us a rate of 1 over 8 plus 1 over 6 minus 1 over 5 times t, but t is, but t minus 3 minus 2. And this is all equal to a full tub, which is equal to 1. Why am I doing t minus 3 minus 2? Because we want to find total time, and that'll just give you the variable for time. But yeah, it looks right. I don't want to do any of this by hand, so I'm just going to use my trusty numeric solver. Okay, typing this in. I'll show you what it looks like maybe at the end. Oh, my mom just came home. One sec. I'm going to pause because my parents just came home. So I got to just go tell them where I am. Okay. I'm back. Alright. My parents just came home from a picnic, so I got some cake. I didn't eat the cake right now, but I'll eat that after I record. But yeah, I finished typing it into the thing. You get x is equal to 13.63 something. Wait, one sec. Let me show you. Alright. It is equal to, or well, I already did it as a fraction. It's equal to this, but if you do this, it'll look like this. Click OK. Oh yeah, it's 13.63 repeating. And then something cool is that it stores it as x. So if I just printed out x like this, like typed in the variable x and clicked enter, you would see this. So now what you can do, just do this command of x stored into a fraction, which is just the same as just math 1. That'll just give you 150 over 11, which is your answer. So, sorry, t. T is equal to 150 over 11. So yeah, pretty trivial with the calculator. If you didn't have a calculator, just combine fractions by hand. I guess it's not a big deal. But yeah. Ooh. Find the sum of all positive, or of all prime positive integers that are greater than 4 and less than 58. Is the only best way to do this by hand. I'll just write them out. Greater than 4, so 5, 7, 11, 13, 17, 19, 23, 29. Is there anyone in between? 27 is not. Then 31, 32, 33 is not. There's a really cool trick called a sieve. I honestly forgot what it is. But yeah. Yeah, I don't know. So then, I'm hearing fireworks. Okay, sorry, this trajectory. 31, 32, 33 doesn't work. 37 does work. 39 is not prime. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51 is divided by 3, 52, 53, 54, 55, 56, and 57 is divided by 3. Okay, adding these all up gives you 5 plus 7 plus 11 plus 13 plus 17 plus 19 plus 23 plus 29 plus 21 plus 27 41 plus 43 plus 47 plus 53. Just gives you your answer of 376, and that is the right answer. Nice. So yeah, pretty just self-explanatory. Just know your primes. You can probably get a program to spit out primes. I might actually invest in making that. But yeah, okay. I guess you can actually, I'll show you how to do this using numeric solver. It's not hard to do by hand. That's the only reason why I'm doing it by numeric solver, because everyone should be able to just do distributive property and do all that. But something cool is that you can literally just, it's a linear equation too. So this is like, numeric solver was practically invented just for this type of problem. So go to math, click up, go to numeric solver. So 332 times x plus 17 minus 16 times 18 minus x equal 152, 4, 5, 6. And then that's going to equal like this. Solving for x. just gives you this. Wow. Oh, interesting. It's not perfectly 600. Sometimes this is just a rounding error because the way it solves it is through approximation. So it thinks that 599.999999998 is pretty much the answer. You'll notice this more for bigger numbers where it approximates perfectly like that. Like if it was like x plus 1 is equal to 2, it'd give you a perfect answer of 1. But with big numbers, they'll do that. So you just round to 600. Like, or you're not going to write 599.9999998, right? It's just 600. So yeah, 600 is your answer. So yeah, 600. I wrote that with my mouse. Okay. Oh, another series. It has to be an arithmetic series, or a geometric series. So which one is it? So I guess to determine, we just divide, right? So for an arithmetic series, is root 27 minus root 12 equal to root 48 minus root 27, right? Is that true? Well, square root of 27 minus the square root of 12 is 1.72. Root 48 minus root 27 is also the same. So it's an arithmetic series. Okay, perfect. So now, I guess what you can do, okay, this is interesting. Splits it off into two parts. So I guess I'm just going to assume that this first part's definitely arithmetic series. So this just turns into 2 root 3. This is just 192 divided by 3 is 64. This turns into 8 root 3. Okay. So remember that trick I showed, or not trick, it was just, so I'm assuming it, and then this is a divided by 3 is, yeah, and this is just 3 root 3. So 2 plus, so root 3 times 2 plus 3 plus dot 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 plus up to 8. That is just 8 plus 2 over 2 times your number of terms, which is 8 minus 2 plus 1, so 7 root 3. So 7 root 3 times 5, so 35 root 3. Second part. Is this also an arithmetic series? Same test. Is square root of 32 minus the square root of 18. That's 1.414. Is that root 2? Oh, that is. Interesting. That is root 2. Okay. So then the square root of 50 minus the square root of 32, that is also root 2. Interesting. Okay. Same thing. This is just 3 root 2. This is just 162 divided by 2 is 81. This is just 9 root 2. And this is just 4 root 2. So same thing, it's just root 2 times 3 plus 4 plus dot 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 all the way up to 9. 9 plus 3 over 2 times the number of terms, which is 9 minus 3 times plus 1 is 7. Root 2 tacked onto that. So 9 plus 3 is 12. So this is 42 root 2. And then you can't combine these, so the answer is just going to be written as 35 root 3 plus 42 root 2. So yeah, and that is your answer. Okay, 2 more. And I guess we are over time because I just noticed we hit 53 minutes. But it's okay because I'm also talking extra, which is probably like an extra like 5, 6, 7 minutes. I don't know. So yeah. All right. How many zeros is 127 factorial end? Okay. These ones, there's like a nice way. Basically, how to get a 0, you just have to multiply by 10, right? Take 81 to get a 0 on the end of that. You do 81 times 10. Same thing for factorials. It's basically asking how many 10s are in this 127, and how do you make a 10? 10 just is broken down into 5 and 2. Now we have a lot of 2s. Every even number gives you a 2, and every power of 2 also gives you a 2. But how many 5s do we have? Well, we can do casework. The best way to do it is number of 5s, right? And then there's a 5, there's a 10, there's all the way up to 125. So that's just 25 to 1. So that's just 25 5s. And you might think that's your answer, but no. You also have to consider that, for example, every 25 you hit, that's 5 times 5. So 5 squared, so 2 5s. So when we have 25 in this mix, there's an extra 5 we're forgetting. So now we have to calculate the number of 25s, right? 25, that's just 25 up to 125, so that's just 5. So there's 5 25s, and now there's one more power. There's 5 cubed. So a general form is just 5 to the first, 5 squared, 5 cubed, up till 5 to the n exceeds whatever number you have. So I'll just say like x factorial, right? So 125, there's only 125 in it, so that's just equal to 1. 25 plus 5 plus 1, that's just equal to 31. So that's just the basic algorithm. Yeah, remember it because you'll be seeing it a lot, and then that's it. Like, you'll be able to do every problem like this by now. It's a very quick algorithm. Okay, last one is a quadratic equation, right? Let's end off strong. I don't think we made any bad mistakes. I guess for one of them we kind of spent a lot of time on, but I still got it. So I don't know. Oh shoot. Ew. Okay, original quadratic equation for x is that form. If c is increased by 4, the roots for x are equal. Oh, okay. So here, x squared, okay, yeah, okay. So x squared plus bx plus c plus 4. Something cool is that b over 2 is equal to, or no, b over 2 squared is equal to c plus 4. Why is that true? Because that's just a perfect square. Like any perfect square where the roots are equal, like x squared plus 6x plus 9, 6 over 3 squared is equal to 9, right? That's just the perfect square. So that's why the roots are equal. Then x squared plus bx plus c minus 5, this is more interesting. Twice the other. So you have r and then 2r. That's equal to negative b. Then you have r times 2r is equal to c minus 5. So what do we even have to solve for? Find the product of the roots in the original quadratic equation. So I think we just have to solve for b and c. So, okay. So 3r is equal to negative b in this case. 2r squared is equal to c minus 5. So 2 times negative b over 3 squared is equal to c minus 5. So then 2 times b squared over 9 is equal to c minus 5. So, and then here b squared over 4 is equal to c plus 4. So then solving for c is pretty trivial. 4c plus 16 is equal to b squared. But b squared is also equal to 9 over 2c minus 5. So 9 over 2 times c minus 5 is equal to 4c plus 16. And this is pretty trivial to solve. I'm just going to use numeric solver on this. Yeah, like you'll notice in a lot of them I tend to use numeric solver a lot because it's like I don't want to make a dumb mistake just making a mistake here, you know what I'm saying? Like I'd rather just like get all the, because ICTM mainly tests you on the logic, but if you can get the logic, the arithmetic's really easy. So C, one sec. Okay, so C is equal to 77. Now let's solve for B. Wait, no, I capped. We don't need to solve for B because product of the roots, I forgot. Yeah, okay, product of the roots is just C over A, remember? But that's just equal to C because A is equal to 1. So R times R1 times R2 is just equal to C. So we found C. Like, I think we're just done. Yeah, C is equal to 77. So that's the answer, I think. Yes, it is the answer. Okay, C is equal to 77. That's the answer, and that's the live solve done. Here are the answers. Yeah, C is equal to 77. Yeah, pretty nice set. I think it was harder than the last one, but yeah, so cool. So I'll upload this video after I go eat my cake. So yeah, see you guys.